Hi, I just wanted to make this quick video in case you missed something during today's lesson. So we, as you can see, are moved on to Unit 2, which is called Atomic Theory and Periodic Table. And this is our first lesson on the history of the atom. So if we take a look at our next slide, we're going to talk about many different scientists today. But the first scientist, or the first philosopher, I should say, that we're going to talk about is a person by the name of Democritus, and you can see a picture of him down here in the corner. So he was the first person to consider the idea of an atom as the smallest particle of matter that could exist. So the term atom actually comes from a Greek word that means indivisible, and Democritus was a Greek philosopher. And this is around 2,500 years ago around 460 BC. So about 2,500 years ago from today, which is 2020. Okay, our next scientist, and this person is an actual scientist, his name was John Dalton. So he was the first person to use science to develop a theory about atoms and how they make up all that we know about matter. And this happened about 210 or so years ago, around 1808. So again, first person to use actual scientific experiments to theorize mass and matter and atoms, and much different than anything that has been done before him. And what we're going to do is we're going to take a look at his 5 postulates, the 5 ideas he came up with way back in 1808. So the first thing that he thought of was that all matter is composed of extremely small particles, which he called atoms, based on Democritus's term of atoms, meaning smallest indivisible particle. And I just put a picture of a gold brick there just as a way to think about this is an element of gold, and that one element, that one chunk, has billions and billions of these little atoms of gold. Our next picture, our next idea from Dalton is the fact that atoms of a given element are identical to each other in size, mass, and other properties. And then atoms of different elements are actually different from each other in size, mass, and other properties. And if we were in the classroom, I would actually have a watch glass, like a little glass dish, with each of these powders that I could pass around to you. And you would see that they both look fairly similar to each other. If you touch them with your finger, they would both feel similar to each other, but they're in fact very different. So carbon is a much lighter atom, so much smaller mass than silver. So even if the piles were roughly the same size, the carbon one would actually be much lighter than the silver one. Okay, the third idea he came up with was that atoms cannot be subdivided, created, or destroyed. So subdivided means broken down into smaller pieces. Created obviously means generated or to make something, or destroyed, of course, means to get rid of something. The fourth idea that he had was that atoms of different elements combine in small whole number ratios to form chemical compounds. The whole idea of a chemical reaction was first kind of thought up by Dalton. Now, they were doing chemical reactions beforehand, but they never really thought about it on an atomic level. So looking at individual atoms and how they're reacting with each other. And his fifth idea was that in chemical reactions, these atoms must be, since they can't be created or destroyed, they have to be combined and separated or just rearranged as part of this chemical reaction. So we're not making anything new. We're not getting rid of anything. We're just taking stuff that's already in existence and changing what it looks like. So that was about 200 years ago. If you fast forward all the way to today, 2020, what has changed since then? So first of all, a given element can have atoms with different masses. We're going to talk about this more in our next class. Those are called isotopes. And second, atoms are divisible into smaller particles, and those particles you've probably heard of are called protons, neutrons, and electrons. What's remarkable, though, is how much has not changed since his original theory. So what hasn't changed is that all matter is composed of atoms. Atoms of one element differ in properties from atoms of another element. Atoms combine in small whole number ratios to form chemical compounds, still true today. And in chemical reactions, atoms are either separated, combined, or rearranged. So they're moved around, but they're not created or destroyed. So pretty remarkable that all of that still holds true today. Okay, let's take a look at our next slide. So what I did here was a little different than what we did in class. I kind of put it all together on this one picture so that you'd be able to see it. So if I start off all the way at the beginning with Democritus, so all the way over here, it says Democritus based his idea of an atom on just a thought. So there was no scientific basis for this. So this is around 460 BC. I have a picture here of a brain and a light bulb going off because it's an idea that Democritus had, and he turned that idea into this word, atom. And a long period of time passed, and it wasn't until around 1810 when Dalton's atomic theory comes out that we start to change our idea of what an atom looks like. So now an atom is much smaller, and we actually use scientific experiments to come up with this idea of an atom. Next, if you notice, about 100 years, a little bit less than 100 years pass, and a guy by the name of J.J. Thomson discovers the electron. He did this using a cathode ray tube, which is sort of what they used to use in old television sets, those television sets that were really wide in the back. And most of you probably don't remember them, but your parents would. So televisions used to be really wide, not wide screen, but wide front to back. And in the middle of it, there would be a giant tube that would shoot electrons at this screen. And then people sitting on the other side of the screen would see that as pictures. So he used that same type of idea to come up with the plum pudding model, which you see over here. So the plum pudding model had these little electrons, so 1, 2, 3 electrons in my drawing, and they're just sitting in this mass of positive charge. And I like to think of it like a chocolate chip cookie. So the electrons are kind of like the chocolate chips, and the cookie part is the positively charged part. And that was around 1897. Then along comes a gentleman by the name of Ernst Rutherford, and he does the gold foil experiment. So the gold foil experiment was basically a way to figure out that the atom is, number one, mostly empty space, and number two, the fact that all of the positive charge is not spread around like we thought back here. Instead, all of that positive charge is concentrated right here in the middle of the atom. So the Rutherford gold foil experiment proved that the nucleus has all of the positive charge and that it's really small compared to the size of the atom. The next one is something called the photoelectric effect. So a gentleman by the name of Niels Bohr figured out the photoelectric effect. And basically this told us that electrons aren't just floating around randomly in the atom. Instead, those electrons are traveling around in energy levels. So this one is referred to as a solar system model because it looks kind of like the solar system, like the planets in a solar system. And from there, we figured out that in 1932, we discovered the neutron, so the particle that has no charge in an atom. And we're going to talk about each of these particles in more depth during our next class. And we also changed, so a guy by the name of Erwin Schrödinger changed what we consider to be our model. So we now call it the quantum model. Sometimes it's called the electron cloud model. And it's basically a slightly different picture where the electrons are in energy levels, but they're kind of in this messy cloud instead of being in these nice straight or curved pathways here. So there's a cloud of electrons and they're kind of moving around, but it's not random. They're contained in these energy levels. Okay, so if you look, this is the original presentation that I did. So I just went through all of these pictures. And I'd like to finish by reminding you that you need to complete this Edpuzzle activity. The activity can be found on Schoology. Please take your time. It is a really nice video that goes and talks about everything that I just showed you here, but it has really cool graphics. and it would help to hear someone else explain it to you. So thanks very much. I'll see you guys.